Imagine, for just a second, that you are standing in front of this massive, incredibly complex industrial pump,
Right.
and the machinery is humming, or, well, maybe worse, it's making this grinding noise that it definitely should not be making.
Oh, that is never a good sign.
Yeah, exactly. So the pressure gauges are fluctuating all over the place, warning lights are blinking, the system is basically failing, and you are the one standing right in front of it.
Real pressure, right.
Right. Now, in the old days, you might be frantically flipping through, I don't know, a giant grease-stained paper manual.
Yeah, just desperately trying to figure out which valve to turn before something catastrophic happens.
Exactly. But instead, you just hold up your phone, and instantly, the screen overlays exact step-by-step instructions directly onto the real-world pipes right in front of you.
It's a really striking image, I mean, when you picture it. You aren't just reading a description of a fix anymore.
Yeah.
The digital solution is actually being physically mapped onto the real-world problem in real time.
Which, I mean, that feels like something straight out of a sci-fi movie, right?
Yeah.
But it's happening right now.
It is.
So, to figure out how we actually bridge that gap between clunky paper manuals and these real-time digital overlays, we are diving into a really interesting stack of sources today.
We've got some great material for this one.
Yeah, we've got articles, technical research notes, and primarily this very revealing white paper. It was released on July 15, 2026 by a company called EON AI Ventures.
Right, and they've just announced a major evolution of their platform, which they're calling Intelligent Field IQ.
Okay, let's unpack this. Our mission for this deep dive is to really figure out how augmented reality, AR, and artificial intelligence are finally stepping out of the theoretical, perfectly safe training room.
Yeah, the simulation phase.
Right, and actually surviving the chaotic, gritty reality of live industrial sites.
Because honestly, that transition is historically where these technologies just die.
Thanks.
Oh, absolutely. I mean, it is incredibly easy to get caught up in how visually stunning an AR demo looks when you're sitting in a pristine corporate conference room.
Sure, it looks like magic on a screen.
Right, but we have to ground this in the actual stakes of the source material. EON isn't trying to roll out, like, a fun new consumer toy here.
No, not at all.
They're trying to close a dangerous gap between practice and reality in environments where the margin for error isn't just, a loss of revenue. It's literally a matter of life and death.
Right, and before we get into the weeds of how this software actually overlays data onto a rusty pipe in the field, we really need to talk about why this is even necessary in the first place.
The context is crucial.
Because if you look at the statistics in our research stack, the contrast between a digital training room and the physical danger in heavy industry is, well, it's just stark.
It's incredibly sobering. The sources point out that despite decades of safety initiatives and regulations, industrial operations remain highly dangerous globally.
Yeah, the numbers are wild.
We are looking at roughly 1,000 people dying in workplace accidents every single day.
1,000 people a day. I mean, when you stop and actually think about the scale of that, it's staggering.
It really is. And when you zoom in on specific high-risk sectors, the numbers remain just deeply concerning.
Like oil and gas, right?
Exactly. In the oil and gas sector alone, a worker is lost every few days on average.
Wow.
These are highly volatile environments. A single misunderstood procedure, or even just, a moment of hesitation, can trigger a devastating chain reaction.
Not to mention, beyond that immense human toll, the financial weight of these failures is massive.
Oh, astronomical.
The text notes that a single serious offshore platform incident can cost upwards of $38 million.
Right, so you have this massive financial incentive from the enterprise side to get things right.
Yeah, and on the other hand, an absolute moral imperative to just keep these workers safe.
Exactly. What's fascinating here is how the source material identifies the core failure of our current digital tools. It claims that almost all of them stop at the training room doors.
So what does that actually mean in practice, stopping at the training room doors?
Well, it means we've built these incredible simulations, right? But we haven't given workers a way to take that intelligence with them into the field.
Ah, I see.
Think about how we currently train industrial workers. They sit in classrooms, maybe they use a desktop computer, or even put on a VR headset in a safe corporate office.
To learn some complex procedure.
Right, all in a totally controlled environment.
It's kind of like learning how to drive a car by exclusively playing a perfectly safe video game simulator.
That's a great way to put it.
You're sitting in a quiet room, And if you crash, you just, hit a reset button.
Exactly, no real consequences.
But the very moment you pass that virtual test, you are instantly dropped into chaotic, real-world rush hour traffic in the pouring rain. The cognitive dissonance there is just huge.
And let's build on that analogy, because it's not just the traffic, right?
What do you mean?
Imagine if, during that rush hour traffic in the pouring rain, your dashboard also started flashing error codes in a language you only studied once, like 6 months ago.
Oh man, that sounds like a nightmare.
But that is the level of cognitive overload a frontline industrial worker faces when a complex machine starts failing in the field.
Because the simulator just teaches you the theory.
Right. It teaches the theory of the machine in a complete vacuum. It utterly fails to prepare you for the environmental stress, the dirt covering the gauges, or the unique quirks of the actual aging equipment.
Or just the sheer adrenaline of a real-time failure.
Exactly.
Which brings us to the technological hurdle that EON AI Ventures is claiming to have cleared here with intelligent field IQ.
And it's a big claim.
Yeah, because how do they actually take the safety of that simulator and inject it into the rush hour traffic of the field?
Right, that's the core problem.
According to this release, a worker can literally just point an iPhone at a piece of equipment or use AR glasses if they need both hands free to hold a wrench, right?
Yeah, the hands-free aspect is huge for actual mechanics.
And then the AI recognizes every single component in seconds.
It's identifying the specific granular parts of a complex industrial assembly almost instantly.
Without the worker having to do anything.
Right, without them having to type in a serial number or search through some massive database.
Here's where it gets really interesting, though. Because, AR has been around for years, right?
Yeah, definitely.
We've all seen those tech demos where a digital arrow points at a physical box or whatever.
Right, standard AR overlays.
But the source makes a huge deal about the fact that this AR, getting the digital instructions to actually stick to the physical pipes and valves, happens with absolutely no pre-built 3D models required.
That is the game changer.
No manual setup and no physical markers. So I just have to ask, how is that even possible?
It sounds a bit like magic at first.
Yeah. If there are no QR codes stuck to the machine, and no one spent 6 months building a perfect 3D digital twin of the factory, how does the camera know it's looking at a high-pressure valve and not just, like, a random piece of rusty metal?
Right. Wow.
It sounds like they built a real-time Shazam for complex machinery.
That Shazam analogy actually works really well to describe the user experience. But the underlying mechanics are what make this a massive breakthrough.
Okay, lay it on me.
To understand the how, you really have to understand the nightmare of legacy AR.
The old way of doing things.
Exactly. Historically, if an enterprise wanted to use AR for maintenance, they had to engage in this painstakingly slow, incredibly expensive process of 3D modeling their entire physical environment first.
Wait, really? The whole thing?
The whole thing. They had to send teams in with LiDAR scanners to map every pump, every pipe, every room digitally before the AR software could even function.
Which creates a massive barrier to entry.
Right.
If you don't have the millions of dollars or the months required to perfectly digitize your oil rig first,
Yeah.
you just can't use the tools.
Exactly. You're priced out immediately. But honestly, the bigger problem is that the physical world is dynamic.
Right. Things change.
Say you spend the money and map the rig perfectly today. 2 weeks later, a pipe gets replaced. Or a valve gets swapped out for a slightly different model.
Oh, I see where this is going.
Suddenly, your incredibly expensive static 3D model is obsolete.
Wow.
The AR instructions no longer align with reality, and the tool becomes completely useless. Or worse, it becomes dangerous because it's pointing to something that simply isn't there anymore.
Okay, so if EON is bypassing these pre-built 3D models and physical markers entirely, what on earth are they matching the camera feed against?
They are grounding the AI recognition directly in the customer's actual existing engineering data.
Existing data.
Yes, instead of building a new 3D model from scratch, the system's AI is trained to ingest standard 2D engineering documents.
Like flat blueprints?
Exactly. Things like piping and instrumentation diagrams or P and IDs.
Okay.
It understands the schematic logic of the facility from those 2D files. So when the worker's camera looks at an assembly, the edge computing AI isn't just, matching shapes.
Right.
It's dynamically correlating the geometry it sees in the live video feed with the logical architecture described in the facility's existing blueprints.
That is wild. So it's translating a flat blueprint into a spatial understanding in real time.
Real time, exactly.
But the source text makes a very hard distinction here between just recognizing an object and what they call functional understanding.
Yes, that's a key phrase.
Because, sure, recognizing a pipe visually is cool, but it's kind of useless if the system doesn't understand what that pipe actually does, right?
This is exactly where we cross the line from a neat visual trick into a genuine operational tool.
Okay.
Visual recognition is just geometry. It's identifying that an object is a cylinder and maybe recognizing, hey, it's a pipe.
Right, a dumb object.
Exactly. Functional understanding means that once those components are recognized, they instantly become a connected, logical model within the AI's brain.
Meaning it knows cause and effect.
Yes.
It knows that this specific pipe connects to this specific high-pressure valve, and if you turn that valve, it impacts a header like 3 rooms away.
All right. It understands the flow, the pressure constraints, the actual purpose of the assembly. It's not just a spatial map, it's a functional map.
Which leads directly into one of the most fascinating concepts in this white paper, something they call the situation room.
Yeah, the situation room.
The text describes this as a flight simulator for your equipment.
That's a bold claim.
Right. And because of that functional understanding we just talked about, this isn't just a static digital manual where you read a PDF on your phone. It's a living scenario library.
If we connect this to the bigger picture, this is where the convergence of simulation and real-world application really shows its value.
How so?
Well, in the situation room, a worker can literally rehearse a highly dangerous, rare event before it ever actually happens on their shift.
Oh, wow.
Yeah, they can run through the exact procedures on digital representations of their exact equipment, testing the limits of the system in a totally safe environment.
But let's bring this back to the real world for a second, because rehearsal is great, obviously, but things still break.
They always do.
If an incident does happen in real life, if that rush hour traffic suddenly comes to a dead halt and alarms are blaring, how does this system actually intervene? I mean, does a worker really want to be holding up an iPhone when a pipe is actively leaking?
And that's exactly why the hands-free AR glasses are a crucial part of the hardware ecosystem here, though, the mobile option is important for basic accessibility.
Right.
But when that failure happens, the system shifts from simulation to providing guided, self-verifying procedures.
Self-verifying.
Yeah, it walks the worker through the fix, step by step, overlaid right there on the physical equipment.
And crucially, it doesn't just tell them what to do and then, hope they get it right.
No, not at all.
The source mentions the system uses photo verification.
Yes.
So the worker performs a step, say, closing a critical valve, and the system uses the camera to verify that the physical state of the valve has actually changed before it allows the worker to move on to the next step.
Which acts as just an incredible safety net.
Seriously.
It mitigates the human error that so inevitably creeps in during those high-stress, high-adrenaline situations.
Because you're not thinking straight.
Exactly. You are no longer relying solely on a stressed worker's memory of a training module they took 6 months ago, or their ability to read a greasy manual in low light.
Yeah.
The intelligence is right there, guiding them and cryptographically verifying their actions in real time.
Okay, so to make all of this look so seamless and easy for the person holding the wrench, there obviously has to be a massive engine running behind the scenes.
Oh, absolutely. There's a lot of heavy lifting going on.
The release outlines 4 specific EON breakthroughs that had to converge to make this a reality.
The 4 pillars.
Right. The source calls them the 4 pillars of the system. But let's actually break these down because otherwise it just sounds like tech buzzwords.
Fair enough.
First, they list Genesis. The text says this is the engine responsible for turning standard procedures into guided AI intelligence. What is it actually doing? Is it just scanning a PDF?
It's far more complex than just scanning text. Genesis is an ingestion engine.
Okay.
It takes a company's unstructured legacy data, those old PDFs, the maintenance logs, the 2D schematics, and uses AI to parse out the actual sequence of operations.
I see.
It turns static text into spatial logic that the system can actually understand and deploy as a step-by-step interactive guide.
Okay, so Genesis builds the logic. Then the second pillar is EON Universal.
Right, and EON Universal is the translation layer we discussed earlier.
One matching the blueprints.
Exactly. It handles the heavy lifting of recognizing and configuring the real-world equipment on the fly without needing those expensive pre-built 3D models. It's the engine that links the logic from Genesis to the physical geometry the camera actually sees.
Right, that's the real-time matching against the engineering data. Then the third pillar is the situation room, which simulates the consequences and allows for that rehearsal we just talked about.
Correct.
And finally, the fourth pillar is intelligent field IQ itself.
Intelligent field IQ is the delivery mechanism.
Just the front end.
Yeah, it's the front-end interface that takes all the logic, all the real-time mapping, and all the simulation data and puts it completely hands-free at the point of work, whether on a phone or through AR glasses.
And the white paper makes a very aggressive point here, which is that none of these pillars work in isolation.
No, they have to act together.
You can't just have real-time recognition without the procedural logic, and you can't have the logic without a way to deliver it hands-free in the field. Only with all four of these breakthroughs acting in concert can rear intelligence actually reach live operations.
That's their core argument, yes.
But you know me, I always approach these massive technological claims with a bit of skepticism. Are we just looking at vaporware here?
It's a completely fair question, but looking at the pedigree of EON AI Ventures provides some really solid context.
Okay.
They aren't some startup that just pivoted to AI 6 months ago to catch a trend.
Right, they've been around.
They have 25 years of experience specifically in immersive learning. They serve over 4,400 institutional customers across more than 80 countries.
Wow, okay, so they have decades of intimate data on how human beings actually interact with technical training and immersive environment.
Exactly. They know the human element.
There's a quote in the release from their founder, Dan Lajerskar, that addresses this directly. He says, for 25 years, we built the best training room in the world. Intelligent field IQ walks out the door into the field where the real accidents happen and where intelligence saves lives. It is intelligent field IQ becoming what it was always meant to be.
It frames the technology not as some isolated random invention, right, but as the natural, necessary evolution of their core mission.
Right.
The training room for 25 years was essentially just phase one. They were building the simulation engine so they could eventually bring it into reality.
Which brings us to the macro view. We've talked about the immediate safety benefits, the step-by-step guidance, avoiding those $38 million accidents.
The day-to-day operations.
Yeah, but the source text pushes much further into the long-term impact this technology will have on global enterprises.
This is where it gets really ambitious.
They are proposing an entirely new category of enterprise data. They outline a vision they call work intelligence, or WI.
And this is where the implications get profound. EON views work intelligence as the modern enterprise's missing system of record.
So what does this all mean? Let's cut through the jargon for a second. System of record gets thrown around a lot.
It does.
I know a company has a system of record for their finances, a system of record for their human resources, their supply chains. But what does a system of record for physical work actually look like?
Think about it this way. Companies currently have standard operating procedure manuals, right?
Sure.
But those manuals only document how work is supposed to be done in a perfect world.
Right, the theory.
Exactly. They rarely capture how work is actually executed in the field. The subtle workarounds, the environmental adjustments, the real-time decisions made by seasoned workers.
A messy reality.
A work intelligence system of record captures the ground truth of physical execution.
And EON outlines an architecture built on 3 layers to achieve this. First is their vision, One System Human 2.0. This is powered by an engine they call the intelligence flywheel. And the result of that engine spinning is the creation of this work intelligence asset.
Yes, the WI asset.
Again, intelligence flywheel sounds great in a boardroom pitch, but what does that actually mean for the operations manager trying to keep an offshore rig running? Are we just talking about an automated feedback loop?
Essentially, yes, but a highly compounding one.
Okay, how so?
Think about the most veteran field engineer on your team. Let's say she has been working on your specific facility for 30 years.
Right, she knows everything.
She knows every quirk, every workaround, every specific sound that a failing pump makes before it breaks.
Yeah.
Usually when that engineer retires, all that hard-earned, highly specific, localized knowledge just walks out the door with her.
And the company is left starting from scratch with a new hire who only knows what's in the theoretical manual.
Exactly. But with this intelligence flywheel, every time a procedure is executed, verified, and completed using intelligent field IQ, the system captures that reality.
Oh.
If a veteran worker finds a safer, more efficient way to navigate a tricky valve, the system learns it. It's essentially downloading the muscle memory, the intuition, and the lived experience of your best workers into the system of record.
So you are turning fleeting human experience into a permanent, owned, compounding digital asset for the company.
Yes.
And then Theoretically, you can instantly upload that exact expertise to the AR glasses of a brand new hire on their very first day.
The intelligence of the entire organization compounds regardless of employee turnover. It fundamentally changes how institutional knowledge is preserved and distributed across heavy industry.
Turning human experience into corporate software.
That's the goal.
And for anyone wondering when the sci-fi future is arriving, the release notes that it's actually rolling out right now.
Not 10 years from now.
No. This technology is already available today on the iPhone through test flight for their design partners and pilot customers, and they have an Android version currently in development.
It's moving fast.
So we aren't just analyzing a theoretical white paper about what might happen in a decade. This is a live deployment happening in the field as we speak.
Which is exactly why understanding the mechanics and the implications of this shift is so critical right now.
To wrap up today's deep dive, let's retrace the core journey we've explored through these sources.
Good idea.
We started in the safe, quiet, but ultimately limited confines of the digital training simulator. A place where mistakes are just a reset button away, but a place that utterly fails to prepare a worker for the sensory overload of a real-world crisis.
Right.
We've seen how EON AI Ventures is pushing a massive convergence of AI and AR out of that simulation room and into the gritty reality of industrial operations.
It's a huge leap.
By utilizing existing engineering data to bypass the need for expensive 3D models, they are bringing functional understanding, guided procedures, and real-time situational awareness directly to the front lines.
And saving lives in the process.
Yeah, they're actively fighting against those 1,000 daily workplace deaths by giving workers the real-time intelligence they need to navigate the chaos.
The transition from theoretical training to practical real-time application is clearly a massive leap forward for industrial safety and efficiency.
But wait a minute.
What is it?
As you were talking earlier about that intelligence flywheel, something dawned on me.
Okay.
We just spent this entire deep dive talking about EON's concept of work intelligence.
Right.
The idea of capturing exactly how physical work is done.
Right.
We are mapping every single pump, every valve, every successful workaround, and every human action into a perfect compounding digital data set.
A complete digital record of human physical execution in the field.
Right. So if that intelligence flywheel is truly successful, and it eventually manages to perfectly map the physical world, the physics of the machinery, and every complex interaction and decision a human makes to maintain it.
Yeah.
Aren't we just writing the training data for the autonomous robots that will eventually replace them? I mean, at what point does this perfect digital asset no longer need the human holding the phone or wearing the AR glasses?
This raises an important question, doesn't it? Because it really is the ultimate logical conclusion of a perfect system of record.
Yeah.
Once the AI fully understands the environment and the physical procedures required to manipulate it, the delivery mechanism could easily shift from an AR overlay guiding a human to an operating system guiding an autonomous machine.
From a safety net for workers to the blueprint for their replacements.
Exactly.
That is definitely a heavy, lingering thought to mull over as you go about your day. Well, that is all the time we have for today's deep dive. Remember, there is always more to learn.
And we'll be right here to help you unpack it. Thank you for joining us, and remember that real-world problems often require solutions that can step out of the simulator and into the chaos.
Keep questioning, keep exploring, and we will catch you on the next deep dive. Goodbye.